My dear students, in this video, we learn about the types of vector. First, polar and axial vector. Polar vectors are those vectors which start from a point and represent a specific direction. Polar vector changes its direction with change of coordinate. For example, we consider here x and y axis. East, west, north, south directions are indicated here with respect to x and y axis. We consider a particle is at origin O. The particle moves along northeast direction and is at point P with coordinate 2, 2 meter. The displacement vector is represented here by OP. Is a polar vector with a starting point and is represented by a line segment along particular direction. The particle changes its coordinate after starting from point O and it is now at point Q minus 2, 2 meter. The displacement vector is represented here by OQ vector. With the change of coordinate, displacement vector also changes its direction. Therefore, the polar vectors consist of fixed point represented by the line along a specific direction. Some examples of polar vectors are the displacement vector, velocity vector, linear momentum vector, force, etc. Axial vector represents the rotational effect. When a particle or an extended body rotates about a fixed axis of rotation, then its angular velocity, angular momentum, torque, etc. are represented by axial vector. Now I explain the angular velocity as axial vector. Let us consider a disk is placed in xy plane. The center of the disk is O and positive z axis is the axis of rotation passing through its center. We consider a point P on the circumference of the disk. The velocity of point P is tangential and there is a position vector, that is r vector, starting from center to point P. The velocity is vectorically represented here. V is equal to omega cross r, where omega is the angular velocity of the disk and it is directed perpendicular with respect to r and v, that is parallel to z axis. To represent the direction of v, we consider here a plane containing omega and r vector. Place right hand on that plane, curl the finger from omega to r, that is here anticlockwise direction, then thumb represents the direction of velocity.
Similarly, we can consider another point Q on the circumference. V represents the tangential velocity of point Q. OQ is the position vector represented by R, and omega, that is angular velocity, this is perpendicular to both V and R. Consider the plane here containing omega and R vector. Place your right hand on that plane. Rotate the finger from omega to R, that is clockwise direction, and thumb represents the direction of velocity V.
Here, uh, for the point P and Q, the angular velocity, it is directed upward direction, that is parallel to z axis. Hence we can say that axial vector does not change its direction with the change of position, but polar vector changes its direction with change of coordinates. I give you another example of axial vector as torque. We know that to move a body we need force, and to rotate a body about its axis we need torque. Torque is the moment of force. Torque is basically represented by the product of force and the perpendicular distance. Vectorically, we can write tau is equal to R cross F, where tau is the torque, R is the position vector, and F is applied force. We can consider the rotation of door as example. Door rotates about the hinge, and the line is known here axis of rotation. We apply force at the end of the door perpendicularly. Consider the position vector R here. Then draw a plane containing force and position vector. Place your right hand on that plane. Curl the fingers from R to F, that is anti-clockwise direction, and thumb represents the direction of torque. So we can conclude that axial vector is the cross product of two polar vectors. Here torque is axial vector, this is the cross product of position vector and force. I think you get a clear idea about polar and axial vector. To get various concepts of physics, you can subscribe our YouTube channel, and thank you for watching this video.